guys, how are you all? I hope everyone is fine and rocking. Okay, today is the last class of trigonometry. We'll be completing the whole trigonometry with these 3-4 problems which are left over in the last exercise. If you have any doubt, to comment me in the comment box and I'll surely revert you back. I want you all to just subscribe my channel and click a bell icon so that you don't miss any of the notification for the further classes. Okay, let us start with the 7th question of this unit. It's given that prove that sine A plus cosecant A the whole square plus cos A plus secant A the whole square is equal to 7 plus tan square A plus cot square A. Okay, we need to prove then the first thing that we need to do is that divide this thing, the left hand side and right hand side. What we are doing here, we are solving the left hand side and getting the right hand side. So first of all, let us copy the left hand side. What it is? Sine A plus cosecant A the whole square plus, be careful with the signs, cos A plus secant A the whole square. Okay, now what we can do, how we can just proceed further, how can we solve this? It's nothing but A plus B the whole square formula, right, in both the cases. So let us expand it. Sine square A plus cosecant square A plus 2 sine A and cosecant A. We have expanded this. It's what it is. It's nothing but is A plus B the whole square is equals to A square plus B square plus 2AB. This is what we are expanding here. This is A square, this is B square, this is 2AB. Fine. The same thing we are doing. We are repeating with it. Be careful with the sign. Just copy this sign and write cosecant square A plus secant square A plus 2 into cos A into secant A. Okay, again I'll repeat. I think I have just said cosecant for the cos. Okay, cos square A plus secant square A plus 2 into cos A into secant A. That's what we're just expanding with using the formula. Okay, now herein we just need to solve all these problems. Since it's a plus, we'll directly multiply this, open this bracket and directly take it. Let's move on to the next step, that is sine square A, copying the same things, cosecant square A plus 2 sine A into cosecant A plus, we're just opening this bracket. Okay, since it's a plus sign in the middle, it doesn't matter. If it would have been a minus sign, then all the signs inside would have been changed, but since it's a plus, it will be same. Plus cos square A plus secant square A plus 2 into cos A and into secant A. Okay, the whole thing, we just got it. Now what we can do, we can just see how can we solve this. Sine square A and cosecant square A, do we have any relationship between them? Yes, we do have, but we'll see with the square thing. We'll use the identities here. Okay, let's see. 2 sine A into cosecant A. Do we have any relationship with the of cosecant with sine? Yes, it is. What it is? Cosecant theta is nothing but 1 by sine theta. Right, this is the formula. Here in cosecant cos square A plus secant square A plus 2 into cos A into secant. Do we have any relationship between cos and secant? Yes. What it is? Secant A is nothing but 1 by cos A, right? Cos theta. Okay, so using this formula, we are just replacing the things. Sine square A plus cosecant square A plus 2 into sine A. We copied all the things as it is. Now we are changing this cosecant A to sine A. 1 divided by sine A. What is cosecant? Reversal of sine. Okay, plus that we are copying, again we are copying as it is cos square A plus secant square A plus 2 as it is into cos A as it is, and the last one changes. Only these two changes are there in this whole line, into 1 by cos A. Okay, Sin A and sin A cancel, cos A and cos A gets cancelled. Now what are we doing here is we are getting all the things together. Okay, let's see how can we do that. Okay, sin square plus cos square A. We do have a identity, right? We know the identity, what it is of sin square A theta plus cos square theta is equals to 1, right? So sin square A we have, cos square A we have, it's a plus. So we'll do these two things together. We'll write these two things together. Sin square A plus cos square A. Okay, we just have written these two things collectively. Again, we are copying all these things in a neat form. We have even cancelled that, right? So these two values are taken here. Now we'll be taking from here cosecant square A plus 2 into 1 is left over, so it is nothing but 2, right? Plus cos square we have already written here, we'll drop it, plus secant we did not take it, so we are taking secant square A plus 2 into 1, it's nothing but 2, right? So seeing these things, what we can presume, this cos square A plus sin square A plus cos square A, what is that identity? Because of this identity it is equal to 1. Okay, we are just replacing this value using the identity, plus cosecant square A as it is plus 2 as it is plus secant square A as it is plus 2. Now what are we doing? Collectively making all the numerical terms at one side. What is that? 1 plus 2 plus 2, what it is? It is 5. Okay, plus cosecant square A. What is the formula for cosecant? What is the identity of cosecant square? What is the identity? It is simple. See, cosecant square theta minus cot square theta is equals to 1, right? So if we want to know what is cosecant square theta, we will be sending this cot to the other side. That is nothing but cosecant square theta is equals to 1 plus cot square theta, right? So this identity will be replacing it here. So what is cosecant square theta? It's nothing but 1 plus cot square theta, A. Okay, we have taken all the numerical values. Now secant square A is left over. The same things apply, the same identity apply here for secant square, but it's for secant square. We have got it cosecant square. Now it's for secant square. Okay, secant square A minus tan square A is equals to 1. Okay, this is the basic identity, but we need to know secant square A, right? So we are keeping secant square here, secant square A as it is here, and we are shifting this tan to the other side of the equation. It will get minus tan square will be changed to plus 1 plus tan square A, right? So this secant square will be replaced by 1 plus tan square A, right? This is the cosecant value, this is the value. We got all the numericals at one side. Now we are very near to the answer. We are almost in the answer. Okay, 5 plus 1 plus 1, it's nothing but 7, right? Plus what's left over? What are the terms left over? It's cot square A plus, this is already gone. What is left again? It's a tan square A. This is the answer. Isn't it equal to RHS? Hence proved. Okay, the next 8th problem is simplify 1 minus cos theta into 1 plus cos theta into 1 plus cot square theta is how much? So let us solve this problem. Let us see what's the common thing here in it. It is 1 minus cos theta, 1 plus cos theta. Okay, first let us take the given value. What is the given value? 1 minus cos theta into 1 plus cos theta into 1 plus cot square theta, right? Now let's see what the common thing is here. It is like we can take as A and cos theta as B. Here it is A and B, right? The same thing. What is the formula what is the identity which pertains to this? a minus b into a plus b is equals to a square minus b square. So we can apply that thing here. Okay, so let us take that 1 square minus cos square theta, right? These both things are simplified to this, into this is done, and what is left over into 1 plus cot square theta, right? So one more thing regarding it is, this seems to be an identity, right? It seems to be an identity. What it is? Let us take the first the identity relating to cos and sine. That is nothing but sine square theta plus cos square theta is equals to 1. If which is nothing but, like, if we see sine square theta is nothing but 1 is 1, and this plus is sent to that side, minus cos square theta, right? So herein, if we see 1 minus cos square theta, 1 minus cos square theta is nothing but sine square theta. So we are using the identity, we are replacing this 1 minus, 1 square is nothing but 1. Okay, 1 minus cos square theta is nothing but, we're using this identity, we are getting sine square theta, right? And 1 plus cos square theta, this also seems somewhat similar. What it is, we have seen that cosecant square theta minus cot square theta is 1, right? But herein, if you see cosecant square theta, we keep it here and we are sending the cot the other side. So 1 will be 1 and the minus cot square theta will be plus cot square theta, right? So this plus cot square theta can be replaced by cosecant square theta here. Yes. So it is nothing but cosecant square theta. Okay, now let us solve in the easiest way, right? Sine square we are copying as it is. There's any relationship between a cosecant and sine? Yes. What is cosecant theta? It's nothing but 1 by sine theta, right? So we are using this formula here. So 1 by, since it's a cosecant square, we will take sine square theta, right? Sine square theta gets cancelled. Answer is 1. It was the simplest problem. It seems complicated, but it is very simple. Once you know the identity, these identities, then there is a no looking back for the trigonometry problems. Many people think that because of these these things, substitutions, many people think that it is very difficult. But if you concentrate on what the question is saying, and you try to just jot down the given values, you will surely get an answer. Okay, let's move on to the ninth one. Let us not waste the pages and just continue with it. Ninth problem. If secant theta plus tan theta is P, then what is the value of secant theta minus tan theta? So, well, in that case, if we get, secant and tan, there's an identity related to that. What is the identity related to secant and tan? Secant square theta minus tan square theta is equals to 1, right? So what we will be doing, we'll be using this identity, we'll simplify, and we will replace this values, and let's check the answer. Okay, so we know secant square theta minus tan square theta equal to 1, right? Okay, now what we see, a square minus b square, isn't that so? So what we will do, we will be going back. What is a square minus b square? What is the identity? A plus b into a minus b, right? So we will be writing the same thing here. What is a in our case? It is secant. Okay, what is b in our case? It is tan. Secant plus tan, secant theta plus tan theta into secant theta minus tan theta is equals to 1. We are just simplifying this using the identity of a square minus b square. Secant is a, tan is b. A square minus b is nothing but secant theta plus tan theta into secant theta minus tan theta, right? So in our problem, from these both things, what is given? This value is already given as p, right? So what we will be doing, this value will be replaced by p. It is given. It's given. Okay, this given value is p. tan theta plus secant theta is nothing but P into secant theta minus tan theta, right, is equals to 1. What we have to find out? Secant theta minus tan theta. So keeping secant theta minus tan theta here, secant theta minus tan theta here, we will be sending this P the other side, okay, other side of the equation. Then what it will be, since it's a multiplication here, it will go the other side and gets the division part. So 1, we are writing this secant theta minus tan theta as it is, 1 is as it is, only P is being changed, divided by P. So this is our answer. Yes, this is what we need, they were asking in the question. Okay, now the last problem of trigonometry, the 10th one. If cosecant theta plus cot theta is k, it is saying that this value is overall value is k, then prove that cos theta is equals to k square minus 1 divided by k square plus 1. So this is one of a kind wherein, this is LHS, right? This is RHS, but herein will not start with LHS, because see, if we take LHS also, we don't know, like cos what we can simplify and get that thing, right? It's better now we take in RHS, because see, RHS has a K, so we can substitute K and simplify and get compressed answer as cos, right? So let us take RHS here. RHS is nothing but k square minus 1 divided by k square plus 1. But we know it's given, okay, but given cosecant theta plus cot theta is equals to k. This is given in our question, right? So we are replacing k with the given aspect. What it is? What is k? Cosecant theta plus cot theta the whole square. Okay, this k is this minus 1, right? Now the whole divided by this k is cosecant theta plus cot theta the whole square plus 1. Okay, we got this. Next step is that we will be expanding it using the formula of a plus b the whole square here. Okay, so cosecant square theta plus cot square theta plus 2 into cosecant theta into cot theta minus 1. See, this value is nothing but this value is in a simplified form. Which formula we are using? A plus b whole square. Identity we are using a square plus b square plus 2ab. Okay, that's what we are doing here, wherein a is cosecant theta and b is cot theta, right? And this minus 1 we have copied as it is, whole divided by same thing we are doing for the new denominator, cot square theta plus 2 into cosecant theta into cot theta. It is plus 1, not minus, it is plus 1. Now we all know one more thing regarding it. Cosecant and cot has an identity, right? So we'll be using that identity. What is it? See, I'm writing here identity. What is the identity of cosecant and cot? Cosecant square theta minus cot square theta is equals to 1. See here, and if this would have been a minus, now the answer would have been more easier. But the case is it's not minus yet, it's plus. Okay, so what we are doing, we are replacing this cosecant square value with the, come on, let's see, cosecant square theta. What will the cosecant square theta be? 1 plus this minus goes there and gets plus cot square theta, right? So what is this? What are we doing? We will be substituting this cosecant square theta with 1 plus cot square theta. So 1 plus cot square theta, okay, plus cot square theta, as it is we are copying this, plus 2 into cosec theta into cot theta minus 1 whole divided by the same thing we'll be doing with the denominator. plus cot square theta plus 2 into cosecant theta into cot theta plus 1. Okay, now what all we can do is, see here, plus 1 and minus 1 gets a 0 right here in, okay, 0. What is left? Cot square theta plus cot square theta is nothing but 2 cot square theta. They are 2 cot square theta. It is plus. It's not a multiplication. If it would have been a multiplication, it would have been a cot to the power 4 theta. Okay, so they are 2 cots, right? So we are taking 2 cot square theta. 2 cot square. Next is plus ka plus. Okay, this one is get cancelled. 2 into, okay, what, let's convert these values, because since the answer we need to get is in cos. So cosecant, what is cosecant? 1 by sine theta, right? Into what is cot? What is the cot value? Cos theta by sine theta, right? Okay, the whole divided by, see here also we have 2 cot square theta plus 2 into what is cosecant? 1 by sine theta into cos theta by sine theta plus 1. Oh my god, I forgot this one here. Okay, okay, now the thing is, now since we converted these all things into cos and sine, let us convert this thing also into cot, this cot into cos and sine. Okay, 2 into cos square theta by sine square theta plus 2 into cos theta divided by, since 1 into cos theta is cos theta, divided by sine into sine. It is not plus here again, you see, it is sine theta into sine theta, it is sine square theta. If it would have been a plus, you would take 2 sine. Okay, sine theta. The whole divided by, this is only the denominator, I mean the numerator we got. So 1 plus 1 is nothing but 2. The numericals one side. Then it is 2 into what is cot square theta, cos square theta divided by sine square theta, okay, plus 2 into cos theta divided by sine into sine, it is sine square theta. Now what the best thing we can do here is, we can take LCM of the things, right? So first for the numerator, what is the LCM for the numerator? It is sine square theta, right? Okay, for both the things we have sine square theta. So the above things are directly copied. So 2 into cos square theta plus 2 into cos theta. Okay, this was the numerator which we have solved. Now we'll be solving denominator. It is 2 into sine square theta. Since this doesn't have any of the denominator, it has 1, so herein we need to add it by sine square theta. Otherwise sine square theta, I mean the LCM is sine square theta here. Okay, so 2 into sine square theta is the answer here for first one. Next is plus 2 into cos square theta, right? 2 into cos square theta. Now this is 2 into cos theta plus 2 into cos theta, right? Sine square and sine square gets cancelled here. Okay. Okay, we just got that 2 cos square theta plus 2 into cos theta divided by sine square theta, the whole divided by 2 into sine square theta plus 2 into cos square theta plus 2 cos theta. Okay, divided by sine square theta. Sine square gets cancelled. It's just that because of the space, I have to continue in another page. So I just copied the same ditto thing which was there in the last page, right? This was the last thing which we have done, ditto. Sine square get cancelled. Answer will be, what will be left over with 2 cos square theta plus 2 cos theta divided by 2 sine square theta plus 2 cos square theta plus 2 cos theta. Okay, we are just removing these denominators. Now this numerator, what are the two common things here? It is 2 cos square theta and 2 cos theta. So what is the common? 2 is common. Also cos theta is common. So we are taking the common thing outside, 2 into cos theta. It means that still if we take out the 2 here, that will not be there, 2 in that. Cos square theta. Okay, cos square theta, 1 is already out. So what it will be? 1 cos theta will be left over, right? Yes, it is left over. Here in 2 cos theta, these both values are already out. What is left here? 1, right? 1. So plus, see, plus ka plus, and this is 1. Okay, we got this. Next thing is that in all these things, what is common? Directly we can't say like 2 cos theta is common. What is common in all these things? 2 is common, just 2 is common. Taking 2 as a common thing from all these three and writing other values which cannot be taken as common. Sin square theta plus cos square theta plus cos theta, right? Common means it should be common from all point of view. You just can't take these two commons and leave the sin square theta. Okay, so this 2 and 2 gets cancelled. Now in the next step, what we are doing, seeing this, sin square theta plus cos square theta, what is clicking your mind? It is identity. What is the identity? Sin square theta plus cos square theta is equals to 1. So replacing the sin square theta plus cos square theta value as 1. See, the above thing we are copying, cos theta into cos theta plus 1 we are copying. Then dividing it and replacing the sin square theta plus cos square theta as it is an identity, we are replacing it by 1. Okay, so it is 1. This value, whole value is 1, and cos theta is still left over. We are taking that cos theta here. So herein you can see cos theta into cos theta plus 1 divided by 1 plus cos theta. It's one and the same. A plus b or b plus a, it's nothing. So this ones are gets cancelled. What is left over in our answer? It is cos theta. Isn't it the LHS? Yes, hence proved. Okay, now this was the last problem pertaining to trigonometry. I have done each and every problem with all the explanations and the formulas, and I request you all to just go and refer the whole formulas of this chapter, so that you will be very quick enough to answer any of the trigonometric ratio answers. And trigonometry is the most easiest chapter. By now you might have got the knack of it, how to handle the problem. Okay then guys, surely I'll be posting coordinate geometry in my next videos. Still, any suggestions regarding my videos or regarding the next topic, do mention in the comment box. Okay, till then, take care, bye bye, have a nice day.